Welcome back to Boiler Wild. My name is Eric Johnson. This is another episode for you to learn more about boilers and steam in this case. I am all about boilers, eat, breathe, and sleep boilers. Boiler Wild is a podcast that I started about a year ago. We are coming up on a year, I believe, in about a month. But WILD in the name stands for work hard, invest yourself, lead others, and develop yourself into a person of excellence who shall always strive to get better. And listening to this podcast, I hope you learn from something I say or something that one of the guests on the podcast also says. I've had some very knowledgeable people on, and I have some more knowledgeable people lined up to guest star on future episodes. So watch and listen for more of that. If you would take 5 seconds to open up your podcast app and to rate this podcast 5 stars, that would help me out a lot. I would love that. That helps other people find this podcast. It lets the podcast apps know that people do listen to this podcast. On Apple, I believe we have 8 5-star reviews, and Spotify, I believe it's 24. And if we could get to 10 and 30, that would be amazing. And if you have any other questions or comments, you can leave a comment in the app, or you can DM me on LinkedIn or email me, eric.johnson@boiler.com, with any questions, comments, or topic suggestions. Or if you know somebody that wants to be a guest, or if you want to be a guest on the Boiler Wild podcast, the #1 boiler podcast by ratings and numbers. Let's get into it. So the steam and condensate loop, this is an important concept and important for everybody to know. And it is one of the most basic concepts in the steam boiler room. We're going to be talking about steam today. Hydronic boilers are technically still boilers, but tried and true boilers, the original boilers, are steam boilers. So this is going to be the steam and condensate loop, only found in steam boiler rooms, because we are making steam. Hopefully with your hot water system, you are not making steam. You are doing something wrong if you are making steam with a hot water boiler. The steam and condensate loop, why is it important to know? It is important to know because when you walk into a boiler room, and this is with my Foundations of Steam System training, this is the goal of when you walk into a boiler room, you should be able to see systems and not pipes. If you see pipes, you need more training. If you see systems, now you can figure things out. Because if you just see pipes and you just see chaos, you're going to get overwhelmed. And if you try to memorize what you see in a boiler room, you're also going to get overwhelmed, because unless you work in one single boiler room and you just memorize, hey, if I open this valve at this time and do this and do that, and you don't know the why behind it, I guess that's fine, but that only works in one boiler room. If you are a service technician, or if you travel around and work with multiple boiler rooms, or you install multiple boiler rooms, you have to know what you are looking at, and every single boiler room looks different. Even if the boilers are from the same manufacturer and it's the same equipment, every boiler room is going to be laid out slightly different, but they all work the same at the core. They will have more or less equipment based on what the customer buys and what the requirements of the system are. But at the very, very core is the steam and condensate loop. And the steam and condensate loop is the core knowledge that you need to know first off when you are learning about steam. And a lot of people will start with, what is a fire tube boiler? What is combustion? What is water tube boiler? All that nonsense. I don't care about that. This is the steam and condensate loop. This is what you need to know. I don't care if you know where the water is inside a boiler. All you need to know at this point is a boiler makes steam through heat. That's all that matters. So let's get into it. What is the steam and condensate loop? This is a loop much like the refrigeration cycle of how water moves around in a steam system. We are going to start off with 4 major sections in the steam and condensate loop. You have the feed water system, you have the boiler system, you have the steam distribution system, and you have the condensate return system. So 4 major systems or sections in the loop. And if you understand the 4 major sections and you can break them all down, and then you can understand that in your mind and build a mental map with every single boiler room that you walk into, you will be golden and you will be able to figure out problems when you have no idea what you're looking at. Because there are so many times I'll walk into a boiler room and I have no idea what I'm looking at, but you have to ground yourself and say, okay, this is where the boiler's at. Okay, where's our water coming from? Okay, that's our feed water system. What is this pipe? All right, that pipe's going to the economizer. So on the other end of that is probably going to be the feed water pumps. All right, got it. And then where's our softener? Okay, got it. And then, oh, what's this pipe? Oh, that's steam distribution to that. There's our head. Okay, I understand that. And that is what you are going for. And this may seem super simple if you are very experienced in steam, but this is the core concept that everybody needs to learn, as I said. So steam and condensate loop, this is where you want to start when you are learning steam boilers and steam systems. And when I say like, oh, I do boiler training, I do steam training or whatever, when I mean boilers, I mean the whole system, boilers, steam, everything. And that involves the steam condensate loop. So once again, 4 major systems in the steam condensate loop. We have the feed water system, we have the boiler system, we have the steam distribution system, and the condensate return system. Now let me break it down. So the feed water system is responsible for providing the initial water to fill the boiler, replacing lost water, purifying it through external water treatment, and storing heated water and pumping it to the boiler. The boiler system is a pressure vessel and an energy source that are combined to turn water into steam. The energy source is commonly natural gas, but can also be fuel oil, propane, biogas, wood chips, or electricity. The steam distribution system. This system is the pipes that guide the steam from the boiler to where it needs to be and ends up at the steam load. The steam load removes the heat from the steam and transfers it to the material or process being heated. Then lastly, you have the condensate return system. This is the network of pipes, tanks, and pumps that collect the hot liquid water, which we call condensate, left over after the steam has given up its heat. And then the condensate is returned to the feed water system for storage and reuse, saving the water usage, water treatment chemicals, and fuel because the water is already heated. And this is the steam condensate loop. And I will clarify that this is an ideal system. Some steam systems, right after steam distribution, right after the steam trap, they will dump the condensate and they don't have a condensate return system and they have 100% makeup. That is fine. And there are other steam systems that if you do a low pressure steam heating system, they may not have much of a feed water system, and the feed water may be just kind of part of the condensate return system. So this is a general system of most commercial industrial steam systems, especially high pressure steam, but the number of components will expand and collapse based on the design of the system and what you need out of the system. But this is the core principle. And if you understand the core principle and what each system does, you will understand why one can go without. But at a bare minimum, you need feed water or some way to produce water. You obviously need a boiler. And the boiler system, is the whole components of the boiler. So you have the pressure vessel, you have the burner or the heat source, you have all the venting and all that stuff that goes with the boiler. And then you got to put your steam somewhere, which is the steam distribution. The thing that really changes the most can be how the feed water system makes up and how the condensate system pulls back if there is a condensate system. But that is the 4 major systems, and that's the high-level overview. Now let's break down what is a part of every single system in those 4 systems. So we're going to start with the feed water system. So we're going to have makeup water supply. This is where it all starts. We got to produce our water from the makeup water supply. This is the starting point of the loop. If you have no idea what you're doing when you walk into a steam boiler room, find the makeup water supply. Where is it coming out of the ground? Where is it coming into the building? Where is the water being supplied from? Typically, it is going to be supplied from a municipal water source, and this is going to be treated water. And treated means for typically human consumption or human use. And this will be like potable water, but it's not going to be treated in the sense for a steam system, and is not going to be fit for raw use in a boiler system. And it is not fit for use because it typically is full of minerals and dissolved gases that will cause issues with your boiler system, and we need to treat it. So we're going to treat it before it enters our storage tank with an external water treatment. And this can look different in a lot of ways, but typically it is going to be a water softener. And a water softener will change and form the hardness in the water, which is the calcium and magnesium, and that hardness will now transform using salts from your water softener. If you have a typical zeolite water softener with the resin, and that will prevent the hardness from ending up in the boiler and scaling up your boiler and scaling up your feed water system. But the external water treatment treats the water before it enters the feed water tank. This treatment primarily removes the hardness from the water using a water softener. There are other types of treatment, external water treatment, which like a reverse osmosis system or a dealkalizer. Those systems are typically used in conjunction with a water softener, but if you have a very basic steam system, you are probably not going to find a RO or a dealkalizer. Those are added typically based on the customer requirements and what they are doing. But just like every other steam system, you can add and subtract, but the core fundamentals are the same. And we need external water treatment before we add our water to our feed water storage tank. And I will say and clarify, external water treatment is going to be different because we are treating the water before it enters the boiler system. And by the boiler system, I mean the feed water storage tank. Internal water treatment is the use of chemicals, and chemicals will be added to the feed water storage system, added to the boiler, added to the steam header, and that is going to treat the water that is part of the system. So that is what external versus internal water treatment means. Next, we have the feed water storage tank. Water is heated and stored in a tank, and so it is available to pump into the boiler when needed. Heating the water before it enters the boiler helps to prevent corrosion and thermal shock in the boiler. And then there are two main types of feed water storage tanks. You have a feed water tank, and then you have a deaerator tank, commonly called a DA tank. A deaerator tank is going to be a pressurized vessel. I know there are atmospheric deaerators, but you're just going the cheap route if you're doing that. A tried and true normal deaerator is going to be a pressurized vessel, typically 5 to 7 psi. The water is going to be around 225 degrees, and it uses steam supply to scrub the dissolved oxygen out of the water. And a feed water tank will be an unpressurized vessel, so it will be vented to atmosphere so it does not build pressure. The vessels will look differently. A feed water tank will typically be lower cost than a deaerator because a deaerator will have to be an ASME rated vessel, and the feed water tank will heat the water inside the tank, but it will only be able to heat it to 180 or 190 degrees. If you go over that, you'll have pump cavitation issues, which is the next part of the feed water system. We have our feed water pumps. And the feed water pumps draw water from the feed water storage tank, and then they pressurize it to overcome the boiler's internal pressure and deliver it to the boiler as needed to maintain the boiler's normal operating level. Feed water pumps are important. Sometimes you can have one pump per boiler, or if you have a modulating feed water system, you can have a manifold of pumps that circulate the water around, and the water will be added to the boiler as needed based on a modulating valve on the side of the boiler instead of on-off. On-off will typically have one pump per boiler, and you may be able to have spare pumps that are added based on some manual valves that you can turn if you need to change the pumps for each boiler. That is the feed water system. Now let's go into what the boiler system is. This is the second major system of the steam and condensate loop. So the boiler system is the heart of the steam plant. The boiler, everybody loves. That is where the steam is made. And boilers will come in all shapes and sizes, but at a basic level, they all work basically the same and turn water into steam. So you're going to have a pressure vessel, which is going to be typically a steel shell and or drums and tubes of the boiler that hold the water and steam. It'll act as a physical barrier through which heat from the fuel is transferred into the water, creating steam. And then the pressure vessel will be constructed in accordance with the American Society of Mechanical Engineers, also called ASME, and that is from the Boiler and Pressure Vessel Code, a Section 1 boiler. You may hear people say this is Section 1 or Section 4. A Section 1 boiler will be a high-pressure steam boiler or an electric boiler or a miniature boiler, and a Section 4 boiler will be a low-pressure steam boiler, so 15 psi and under for an MAWP, or a hot water boiler that is under 160 psi and 250 degrees Fahrenheit. Then you will have the other parts of the boiler system. So you'll have water level and quality. So we always have to maintain proper water level in a steam boiler. A steam boiler will always have water, and then it will have a steam space. This is in contrast to a hot water boiler, which will be 100% full of water and will not have a steam space. If you have a steam space in your hot water boiler, you are doing something wrong. The proper water level in a steam boiler is critical for proper operation. The water level is controlled by the boiler's water sensing control, and the boiler must always have the proper water level in order to operate safely. If you look on the side of a boiler, of a packaged boiler, you will see typically a marking, and this will be the normal operating water level or the lowest operating water level, and that will typically line up in the center of the gauge glass that is going to be on the water column of the boiler. But that is what the manufacturer has specified and said, hey, this is the minimum water level in the boiler that it can operate safely without damage. Next, you have water quality. Water quality is important to maintain good steam quality and preventing corrosion and damage to the boiler. The boiler uses blow-off valves to periodically flush out the dirt and minerals left behind after the water has been turned to steam. So this will look like a bottom blow-off valves. It can also look like a surface blow-off valve or continuous blow-off valve on the surface blowdown or bottom blowdown valves. There'll be two different systems. The bottom blowdown valves or blow-off valves will be for the sludge and the stuff that falls to the bottom of the vessel or the steam drum or the mud drum, and the surface blowdown or surface blow-off valves will be for the stuff that is floating near or on top of the water level. But we have to maintain good water quality in order to have good steam quality. We do not want water leaving with our steam that makes wet steam, and wet steam is bad steam. Then we have our pressure systems. So we have to keep you and others safe, And the boiler has pressure controls to ensure that the steam pressure is correct and the boiler pressure vessel is not over pressurized. And this is going to typically look like a modulating control or a operating pressure control or a high limit pressure control for the steam system. And that is going to make sure that if the boiler has a maximum operating working pressure of 150 psi, that we are staying under that 150 psi and we are operating the pressure of the boiler correctly. So say our set point is going to be 120, we are going to maintain 120 psi inside the pressure vessel of the boiler. That is the pressure systems, and those pressure controls can also be integrated into the electronics typically now, and they will you'll have a pressure transducer that will essentially be your modulation control. That modulation control will be part of your fuel system, and instead of a older style boiler with a linkage control, the modulation controller is its own pressure control up on the control tree. But that's details we'll worry about later. Then you have your fuel systems. This is the energy needed to turn water into steam. Fuel system will use combustion to transfer the fuel's energy into the water. Then it will raise the water temperature until it reaches the boiling point and turns into steam. So most fuel systems are going to be using natural gas as a primary. You will also have propane. You can also use solid fuels like coal, wood chips, or anything like that. You can also use electricity. Technically, electricity is not a fuel, but in this case, let's just call it a fuel because electricity is just a heat source, and we are trying to be simple here for explanation. And if you always fill training with a bunch of asterisks and not reallys, then people get confused. So when I say fuel system, just lump in electricity with that. Then we have the draft and vent system. A boiler needs a constant supply of fresh air to the fire. All boilers that use combustion will need fans to push air into the burner and a vent or stack to safely direct products of combustion to the atmosphere. This includes atmospheric boilers. Most high pressure steam boilers will be a forced draft boiler, but there will also be atmospheric boilers, and they use natural draft to bring in air into the combustion process. So for a boiler, you can have a fan. You also cannot have a fan, but for any boiler that's on the larger side, over 100 horsepower, you're probably not going to find an atmospheric boiler, and you are going to find a forced draft boiler at a minimum, which will have a combustion air fan on the burner or part of the system. Another note with that is electric boilers do not need a fan because it does not use combustion, and they also do not need a vent or stack because there is no combustion process. So keep that in mind. That is also a pro when installing an electric boiler, but there will be no draft or vent system when you have an electric boiler. The last part of the boiler system is the boiler external piping, and this is the piping leading to and from the boiler pressure vessel up to and including the first valve or valves on the piping. The piping used on the water column, bottom blow-off, feed water, and steam outlet is an example of boiler external piping. And this is going to be typically the piping that is sent with the boiler, and the boiler manufacturer will include all this. If you have in a packaged boiler and you'll have all the piping up to the first valve, that piping is all part of the boiler external piping, and that is all governed by ASME, and the boiler manufacturer makes sure it's all correct, and then you make your connections to on the inlets of those valves or whatever the boiler manufacturer supplies. This is mainly seen and messed up on the steam outlet. You will typically have a spool piece or an outlet piece on your steam supply that is before or in between the valves, which is going to be your non-return and your stop valve on your steam supply. And those are part of the boiler external piping, and they have to be made per ASME. and you cannot just randomly weld up some random pieces of pipe and stick them in there. Those are part of the pressure vessel and part of what the boiler manufacturer should supply as part of a package system, but just keep that in mind. Next, the third part is the steam distribution system. So once the steam leaves the boiler, it enters the pipes that carry the steam to where it needs to go. And the primary parts of a steam distribution system are the steam header, and that is going to be a collector pipe that receives steam from one or more boilers and directs the steam to the rest of the system. Steam header is typically found in the same room as the boilers, but doesn't have to be. And you will notice the steam header because all the boilers, if you have two or more boilers, will typically go into a larger pipe that will act like a manifold. And that is how you will set up a steam plant and balance all the boilers instead of trying to balance the boilers and, oh, these boilers run that side of the plant and these boilers run that side of the plant. All the boilers, all their steam outlets will collect into the steam header, and then that steam header will distribute the steam as it's called for in the steam distribution system. Then you have the steam mains, and these come off the steam header, and this is where steam travels down the pipes and carries it in the general direction where it is needed. And then off the steam mains, you'll have branch lines, and those are smaller pipes that come off the steam mains to deliver the steam to the load. And then the steam load is where the majority of the steam's energy is transferred to perform a specific task, such as heating water, sterilizing equipment, heating air, or increasing humidity in the air. The steam load is where the magic of steam and latent heat transfer typically takes place. And next, you have a drip leg. So as steam leaves the boiler, it begins to lose heat. And when this happens, some of the steam will turn back into a liquid, which we call condensate. The condensate flows into drip legs, vertical sections of pipe that collect it, so steam traps can direct it to the condensate return system. And drip legs need to be installed anywhere condensate will collect in the system, such as low points, changes in elevation, before control valves, and along long sections of steam mains and branches. So after the steam leaves the boiler, we need to make sure that we are getting water out of our steam distribution system. Water, aka condensate, is the enemy of a steam system. And if you have too much condensate building up in the system, you're going to have water hammer and you're going to have steam quality issues. A drip leg is the vertical pipe that is coming off the bottom of a branch line or a steam main or a steam header, and that is going to collect the condensate and get it out of the system. And we separate the condensate with a steam trap. A steam trap traps steam. I know, that's wild, but thank you for the person who named a steam trap. They didn't make it complicated. A steam trap is an automatic valve that stops steam flow but opens to push out condensate and air. Condensate buildup acts as a barrier to heat transfer, reduces steam quality, and causes water hammer. We do not want condensate buildup in our steam branch lines and steam mains and in our loads. If we build up condensate in a heat exchanger, we are going to reduce the capacity of the heat exchanger, and whatever you are heating in that heat exchanger, you'll have a steam to maybe hot water heat exchanger. You will have a reduced capacity and your hot water will not get to temperature, and or you will not have the amount of flow rate for temperature for your heat exchanger. So we need to make sure our steam traps are sized correctly and are correct for the system. But steam traps separate the steam and condensate and are very, very important for the steam distribution system and for the entire steam and condensate loop. Last but not least, we have the condensate return system. So after the steam traps push out the condensate, the water needs a way back to the boiler room. The condensate return system collects the hot liquid and moves it back to the feed water system. And returning this water saves the facility money because it's already treated. and it retains valuable heat. The primary parts of a condensate return system are the condensate return lanes. So this is going to be the pipes that carry the liquid condensate away from the steam traps. And because the condensate is very hot, these pipes must be properly sized to handle both liquid water and small amounts of flash steam. When you have water that is hot and pressurized and you take it from a higher pressure to a lower pressure, some of that hot water will flash off into steam. That is called flash steam, and we will worry about that later. Just know that that exists. You'll have a condensate receiver tank, and this is not always, but this is one of the things that you can find in a condensate return system. A condensate receiver tank is a collection tank that gathers returning condensate from different areas of the building, and instead of running long and dedicated pipes from every steam trap all the way back to the boiler room and gravity draining everything or draining it with pressure, the water first drains into these local receiver tanks and then is pumped back to the condensate collection point inside the boiler room, which is typically part of the feed water system. You'll have condensate pumps on those condensate receiver tanks, and because water is heavy and it needs to travel long distances or flow uphill, gravity alone is not always enough to get it back to the boiler room, so condensate pumps discharge the collected water from the receiver tank and return it directly to the feed water storage tank or another tank that we'll talk about shortly here. And then most condensate pumps are electric, but you can also use a steam-driven pump, which is typically called a pumping trap or a steam mechanical return pump. Those are other options if you don't want to use electricity. And then this is also another optional part of a steam system, but you'll find it on larger steam systems typically, is a surge tank. And a lot of people will put this in with the feed water system. I like to put it in with the condensate return system because its primary use is to handle surges of condensate and kind of even out and smooth out the system and to store extra water. So a surge tank collects returning condensate from various sources and provides additional storage capacity needed to handle fluctuating loads and peak flows within the system. Inside the vented collection vessel, the recovered condensate mixes with fresh raw makeup water, which is automatically added by a float-controlled system or a pressure level controlled system to maintain a safe minimum water level inside the surge tank. And then transfer pumps then push that blended mixture of water out of the surge tank and send it to the deaerator and then directly to the feed water pumps, so then the water can get reused in the boiler. And that is the condensate and return loop system. You will also have, and I didn't include it in this initial overview, but you can also have economizers, and that can be part of the feed water system or part of the boiler system. I am not sure yet what I officially want to use it as, but an economizer or a feed water economizer is where you heat up the feed water using exhaust heat from the stack of the boiler. It is going to be located at the boiler stack, and it uses the waste heat before it goes up into the atmosphere and heats up that water. And that is how you increase some efficiency in your boiler system. But I am not sure. I'm still debating on where to put that in the steam and condensate loop, and going back and forth on whether that's part of the feed water system or part of the boiler system. I'm not sure yet. Let me know what you think. But that is the entire steam and condensate loop. And if you can understand that loop and understand what all those things do, and then you start understanding what they look like, and you can trace it out in your head and visualize it, you will be golden walking into any single boiler room that is not crazy. Most boiler rooms are not crazy, and they are very average, and they don't have all these weird systems. If you get into a crazy boiler room, you may get a little confused if they have a bunch of weird stuff, such as an RO system, or they have multiple feed water tanks or deaerators for different things. But a typical boiler room will only have one DA and one surge tank, a couple boilers. It'll have a header. It'll have a condensate return system, and the feed water system will be all the same as well. But visualize that, the steam and condensate loop. Listen to this episode over and over again if you don't understand it. The next time you go into a boiler room, find your makeup water. Ground yourself in the makeup water. That is the water coming from the city water supply or coming from a well supply, depending on where your boiler room is at. And that is the supply to the system. And then from that, you should go to external water treatment. And then we got to store that water. And then we got to pump that water into the boiler. The boiler makes steam into the header. The header sends the steam out into the system. The steam will get used for its heat or its pressure. The steam traps then separate the steam, and the condensate sends the condensate out, and we will either dump the condensate or we will collect it back into the boiler room, and typically we'll collect it using condensate receivers, and we'll pump all the water back. We can also use gravity and the force of steam to drain it back without condensate receivers, depending on the system. But that is the steam and condensate loop. This is the number one thing you need to learn if you are going to learn a steam system. And this is for typically the commercial industrial boiler systems, I would say light industrial. And this is not going to include a low pressure heating system. You can have a low pressure heating system like this, but the basics of a low pressure heating system, you can just have a boiler and a condensate tank with a little steam distribution system. It is going to be much, much simpler than what I just said, but the basics are still there. So go out, trace it out, draw it out on a sheet of paper if you get confused, but it's also good to draw it out. But draw out the steam condensate loop, post it online, or send it in a DM on LinkedIn, or email it to me, eric.johnson@boilearn.com. I want to see your steam and condensate loop drawings, and maybe I'll send you a boiler's hat if you send me a drawing and I like it enough and you tell me what you learned from this episode, because I appreciate people who listen to the Boiler Wild podcast, the number one boiler podcast right now. So thank you for listening to this. This is the steam and condensate loop. Share it with somebody who needs it. If you learned something or enjoyed this episode, please rate the podcast 5 stars. That would help me so much trying to grow this podcast so that we can get the knowledge out to the people who need it. I appreciate you for listening, and stay wild.